Perseus, the major star is Algol. That is Algol Beta Persei. It's not the brightest star in the constellation. It's the second brightest, but it's quite famous because it's the prototype of all eclipsing binary stars. It's an eclipsing with a companion star, and it was the very first one encountered. Sagittarius contains Sagittarius A. Sagittarius is at the center of the Milky Way Galaxy, and Sagittarius A is the black hole at the center of the Milky Way Galaxy. It's really full, of course, since it's the center. You're looking through the disk of the galaxy, tons of gas and dust in your way when you look, so it's pretty hard to see a lot of detail there in optical wavelengths. Chandra has done some amazing observations. It might be its legacy is the work that it's done with the Milky Way Galaxy. This shows the little X here shows exactly where Sagittarius A is located, and you can see it's right next to Scorpius and Antares. And this is an image from the Chandra survey of the center of the Milky Way Galaxy, centered on Sagittarius A. And if you go to the Chandra website, you can see an animation of this, and there is all of the information you would ever need on Sagittarius A because they have done a lot of work in that area. Also in Sagittarius, there are two, as I say, it's a very, very busy part of the sky. It contains two star formation regions that are studied a lot, that are quite major. One is M8, the Lagoon Nebula, and the other one is the Omega Nebula, M17, which is also called the Swan Nebula. Scorpius, the constellation Scorpius, has Antares, the heart of the Scorpio. You can see it's an M-class star, so it's very cool. You can see it's luminosity class 1. So that tells you we have a very highly evolved star, left the main sequence a long time ago, and is getting towards the end of its lifespan. Antares is the orangey star in this image, and you can see all of the components of a star formation region. Actually, this is the Rho Ophiuchi star formation complex. Very busy. It has the dark opaque clouds of gas and dust, the cold molecular clouds, where all of this star formation starts. You see the blue reflection nebulas, the red emission nebulas, and you see that there are newly forming stars there, and you can see stars like Antares that are at the end of the journey. This is Serpens, the serpent. The Serpens is kind of an odd little, again, constellation. It's in the southern hemisphere. It is, partly, because actually it's Ophiuchus is the part in the center. Remember, Ophiuchus is the serpent holder. Well, it is holding the serpent, which has a head and a tail, two different pieces to it. It is, and within Serpens is M16, the Eagle Nebula. Now, the Eagle Nebula is only 6,500 light years away, so it's pretty close. And if you look at this image, you can see where Ophiuchus is. It's right along the plane of the galaxy. Antares is next to it, so Ophiuchus is all above the plane of the galaxy, along with Scorpio and Antares. Here is Serpens up here. So this is where the snake is that Ophiuchus is holding. And M16 is one of the most photogenic star formation regions that we have. This particular image was done from Kitt Peak. And however, Hubble has taken serious advantage of the beautiful components of stellar evolution in the Eagle Nebula. And this part right here ended up being, I think, the 25th anniversary release image for Hubble. This part here was released many, many years ago called the Pillars of Creation. And this is what they look like in close-up. Here's the Fairy Nebula here. Here is the Pillars of Creation over here. Only this one shows you more of it, so it shows you the how tenuous it is, how fragile it is, how thin the gas and the dust is getting here, because all of these newly forming stars, these protostars, these massive stars that are trying to form at the tops of these pillars, are photoevaporating away the gas and the dust around them through serious ultraviolet radiation. So they're destroying the gas and dust around them. And you can see several places here where there are tiny little clumps trying to form. And way down in the right-hand corner, you see a column of gas and dust way back there, also trying to form new protostars that will become stars. All of these pink stars that you see surrounding it, those are all newly formed stars. They have formed, they've eroded and evaporated away the material around them, and now there they are on their own. Taurus, constellation Taurus has Aldebaran. Again, Aldebaran is a classification 3, so it is, and it's a K, so it is a large, cool star on the red giant branch. And within the Taurus constellation is the Crab Nebula. The Crab Nebula is a type 2 supernova event, that a star that collapsed into a pulsar, a neutron star that rotates. This particular image is a composite image. The yellow is what Hubble sees in optical. The red is what Spitzer sees in infrared. And the blue pulsar in the center is what the Chandra Observatory sees. And there is tons of material on the Chandra website for the Crab Nebula. Also in this constellation is the Tauri Protostar. Tauri is that orangey star in the center. Next to that orangey-looking cloud of gas and dust, that's called a Hines Variable Nebula. You don't have to be concerned with that. But Tauri is a protostar stage unique to sun-sized stars. So if you have a star that's, say, sort of between 0.8 and well, I think they're usually around 2, between 0.8 and 2 maybe solar masses. A protostar of that mass that's going to form a star about the size of the same mass or size of the sun. It's very, very irregular. It varies in brightness a lot. It's very energetic. It puts off all kinds of X-ray flares. You know, it just goes through poor hell trying to become a star. It's unique to that mass star when it forms. So a Tauri is the protostar stage to the sun and sun-like stars. Tucana, again, southern hemisphere, with the small Magellanic Cloud. And the small Magellanic Cloud is about 200,000 light years away. And you can see here that it is in Tucana, but that little teeny tiny piece of it sort of crosses the line into the constellation of Hydrus. And this is an image, close-up, nice image of the small Magellanic Cloud. And you can see that there are some bright blue areas there where star formation regions are taking place. That big clump on the right-hand side, that's Tuc 47, which is the most massive globular cluster associated with the Milky Way Galaxy. And if you look inside one of those star formation regions in the small Magellanic Cloud, you will see other very identical to the ones that, of course, that we've seen already. You see stars, you see pillars of gas and dust, where all of this material has been evaporated away by the forming stars. Ursa Major and Ursa Minor, of course, the Big Bear, Big Dipper, Little Dipper, however you call them. You are responsible for Mizar and Alcor. Of course, those are the double stars that you can barely see that they're double. in the handle of the Dipper asterism. That is actually a 6-star system. Mizar is a binary, and Alcor has 2 binary systems, so that's actually 6 stars. And they're all of us the same stellar classification, A, and they are main sequence stars. Ursa Minor has Polaris, of course, the North Pole star, for now anyway, until precession causes it to change its position in the sky. Polaris is a supergiant star. It has a luminosity of 1, and it's very erratic, radical variations in light. It's very problematic, undergoing all kinds of changes in brightness as it moves. It's still an F stellar classification, but it is on its way towards it's probably about maybe halfway through its lifetime. I'm not exactly sure, but it's starting to show its age.